As we start to look at the triangle inequality theorem, we really get posed with two questions. The first being, is the object or is the information we have form a triangle? And the second is, what is the possible third side? So we start off if it makes a triangle. And what's going to happen is you're going to get three side lengths, and we have to make sure that the longest side is less than the sum of the other two sides. What that means is, let's say it wasn't. Let's say our longest side in our triangle was 10. And then the two other sides were 4 units and 3 units. If that were to happen, the two little arms of 4 and 3 are not long enough to cover the span of the gap that the 10 has created, how far apart they are. It's like a T-Rex with little arms. The little arms cannot reach, they cannot close, it does not form a triangle. So we have to find a situation in order to make a triangle where the longest side is less than that sum of the other two. And equal doesn't even work because equal would then create a line, has to be bigger than them. And from that we take, well, what if we get two sides and we want to find the possible third side? So if I said 10 and 18 are two sides that I have of the triangle, there's not one specific value that works. There's a lot of answers that do work for us, but there are also certain ones that don't. Now we could start sitting there and pick numbers that we know for sure don't work. Like 100 is probably not going to work because we're picturing the T-Rex with little arms if it was 100 units. Well, 50 probably not, 40 maybe. We're kind of getting closer. What if we said 30? What if we went 25? What if we went 20? We want to figure out a rule that helps us with that. And so adapting the is it a triangle inequality to the difference of two sides and the sum of two sides giving you the range, we could look at 10 and 18 with their difference being 8 and their sum being 28. The possible values would be between 8 and 28. And we'll look at that more in a moment. Other things we get here is the ordering or the naming of the longest side or the largest angle within a triangle based off of information that we have. Now normally if I give you 3 angles in a triangle, you can tell me which angle is the largest or smallest based by their value. But what we can also do is say that the longest side is opposite the largest angle, and the shortest side is opposite the smallest angle. And this will help us in ordering and listing things that we have. So let's start with the inequality theorem. So I have 3 sets of sides, and I want to figure out if it makes a triangle. 8, 17, and 24 has 24 being the longest side. So I have to answer the question, is 8 plus 17 going to be bigger than 24? And I get 24 is less than 25, which is true, so it makes a triangle. And that's really all we're answering here is the values we have enough to make a triangle. From there we can do other things with it, but more so is it what if we don't have a triangle? We can't really do much else with it. Next one, 7 is less than 3 plus 3. Well, 7 is not less than 6, so no, that does not make a triangle. Now even though 2 of those sides are the same, they're not enough to reach. It's the 2 little T-Rex arms. It's not enough to reach the 7 units. The last one we have here, 24 is the largest side, so it's 24 less than 11 plus 12. Well, I get 24 less than 23, although close, no, it does not form a triangle. So it's just a yes or no on that first type. Now, possible third side. So I have 14 and 22. I'm going to do 22 minus 14 and 22 plus 14 to get the range of values. 22 minus 14 is 8, and 22 plus 14 is 36. So my third side is between 8 and 36. It does not include those values though, so we need to write this as between 8 and 36. So 9, 10, 11, 34, 35, any decimal value between them do work, but 8 and 36 do not. What's nice is if we maybe had a list of values and we had to figure out which ones do work, we can always go back to test. So let's say we look at 10. Well, does 10 fit into this? Well, we know 10 is between 8 and 36, but you can always go back to this first test and say, well, if it's 10, 14, and 22, we get that 22 is less than 10 plus 14, or 22 is less than 24, so we know it checks out. What wouldn't work is 8, 7, 6, 36, 37, 38, on from there. Now, as the two numbers we have get closer to each other, it actually increases the range of values that we have compared to them. So I have 31 minus 28 and 31 plus 28. So we get 3 and 59 is where our third side is between. So we say between 3 and 59. And what a lot of students start to do is they just say, oh, they see 3 and 59 and those are the values that work. And it's not those values, it's every value in between them. Last one, we have 10 and 10. So I'm going to go 10 minus 10 and 10 plus 10. Now this is going to be an isosceles triangle because we have two of them as 10. So our third side is between 0 and 20. Now 20 is the high end. If it's more than that, the little T-Rex arms don't close, but we also say any value bigger than 0. So technically 0.00001 would be a possible third side. It would be a very skinny, slim triangle, but it would work in this scenario. So what we'd answer here is we would say between 0 and 20. Alright, so let's use it a little bit different ways here. Order of the angles from least to greatest. So the smallest angles be opposite the smallest side. 17 is opposite to A, so angle A is the smallest. Next largest side is 20. 20 is opposite to the C, so that's angle C is the next. And then our largest is opposite to 24. The only one left, it has to be angle B. So least to greatest would be angle A, angle C, then angle B. Next, do the three sides make a triangle. Now don't trust the fact that I drew a triangle here, mean it works. We don't usually draw them to scale. We use our rule. 18 is the longest side. Is 18 less than 6 plus 14? 18 is less than 20, so we say yes, it forms a triangle. And don't just write yes or no. Actually write out the rule here to show that you understand why this works and not just, look, I made a triangle and put numbers there. For the next one, what is the possible third side if we have 24 and 7? So I'm going to go 24 minus 7 and 24 plus 7. So we get 17 and 31. So the values of a possible third side are anything between 17 and 31. Make sure you write the inequality and indicate it's between those values. If I had a list of values that I was looking at to see which ones could be possible third sides, 17 would be no. 18 could be yes, 19, 20, 21, 25, 30 would work, 31 would not, 32, 33, anything outside that range is also a no. So be careful using that rule correctly as you go through. Next we have a triangle. We got some values, some expressions for the angles, but we need to figure out the sides from largest to smallest. What we have to do here first is solve the angles algebraically to figure out what the angles are. Then we can go back and figure out the sides. So I know all three angles have to add to 180. So 2x plus 6 plus 10x minus 11 plus 3x minus 10 equals 180. So we have a 15x minus 15 equals 180. So it becomes 15x equals 195. We then get x is 13. And now we can go back, draw a triangle, start labeling things. So if I have J, K, L. So if x is 13, and I'm going to go to k first, 13 times 10 minus 11 is 130 minus 11, so that's 119. Then we have 3x minus 10, so 3 times 13 minus 10 gives me 29. And then 2x plus 6, 2 times 13 plus 6 gives me 32. It'd be a really good idea to make sure these add to 180 here. 119 plus 32 plus 29 is in fact 180, so I'm good there. Now they want us to name the sides from largest, make sure you get the order right, largest to smallest. Largest angle is K, I'm going to list the angles first. So I go angle K is the largest, next is angle L, and third is angle J. Oops, switch those two. J is the middle, L is the smallest. So that's large to small. Now when I name the sides, I want the side opposite them, but a little thing that helps this is the side that's opposite to the angle doesn't use the same letters. So angle K is opposite JL. In triangle JL, or JKL, JL are the other two sides. So JL, largest side. Opposite to J is the other letters, KL. And opposite to L is KJ. So our list is right there. Alright, last set down here, we need to determine the longest and shortest side. And we sometimes get in trouble here because we want to automatically look at the largest angle. But this angle is 80 degrees, and so in this triangle, BD is the longest side. But the 80 degrees in this triangle has nothing to do with this triangle over here. We don't know if they're the exact same size. We don't know if any sides congruences, really except that common side. So what I would do is list out the sides in order from smallest to largest. So let's start with this triangle. So in this triangle, our shortest side is AB, because it's opposite to 32. That's less than the next side of BD, which is less than the longest side of AD, because it's opposite to 78. Now for the other triangle, shortest side is DC. The next one is BC, and then the longest side is BD. So that ranks them separately, but we have to look at what they have in common. They have a common link between them, and that is BD. So whereas BD is the middle length side in the first triangle, the one on the left, it is the largest in the one on the right. So that means although it may be the largest here, it ranks second in the top triangle, so AD is larger than all other sides. So that would be our longest side. Now, we come over to the next one and we look at the shortest side. So we're going to do the same thing writing the inequalities and see what we notice. So the first one, I'm going to go smallest to largest again. 28 is the smallest. That's opposite to AB. Then we have BD is next. That's opposite to 34. And then the largest is AD. For this triangle, the shortest is BD. It's opposite the 25. Next is CD, and then the largest is BC. Now I'm looking for a common link between the two. BD is the common side. Now if I'm looking for the shortest side, the candidate from this triangle is BD, but the smallest one in this triangle is AB, which beat out BD. So overall, the shortest is side AB.